Okay, hello everybody. So we're gonna explain this notation here and here. And this is just really useful notation because it allows you to write things much more quickly and fluidly. And so that opens your brain for thinking about other concepts. Okay, so first I'll just give an example in dimension 2, first in pictures. So here's my two-dimensional space, and I'm going to pick this point, 2, 3. So we would say that 2, 3 is an element of R2 in symbols or formulas. So I'll give that the formula color. Okay, because we're going to use words, pictures, and formulas. And then just briefly, I'll draw another picture of two-dimensional space and the point 2, 3. But now I'm going to think of it as an arrow. 2, 3. And so here, these two pictures are really the same thing, which is just a point in two-dimensional space. But now we're going to think about it as an arrow, as a movement, that we're moving this way, moving this way. We're moving with a certain length and a certain direction. And actually, all of these would be the same vector, 2, 3, 2, 3. Okay, now let me use words. So x in Rn means, what does it mean? It means x is an element of the set called R to the n, or Rn for short, of n-dimensional space, or we could even say of points. Yeah. So points is the word we use when we're thinking like this. Points in n-dimensional space, or vectors in n-dimensional, or really we could say n-dimensional vectors, n-dimensional vectors. And we'd say this when we're thinking of the arrow. Okay. So when we draw the arrow like somewhere else, we're really sort of thinking of a new coordinate system based there, or based there. Because this is the point 0, 0, and then this is the point 2, 3, and then the vector goes from 0, 0, and ends at the point 2, 3. Yeah, okay. Now I might add more words. We can write, or let's say when we write this, we usually name the individual components, so components or numbers, like this. So I'll use the formula color again. X equals x1, x2, all the way up to xn. So when we write x in Rn, and usually we can say in, so we read this x in Rn, x in Rn. Then we're thinking that really we've given these, where each x sub I, and so I'm just sort of referring to x1, x2, x3, except I want to refer to all of them, so I give it this little index variable, I. Each of the x sub I is an element of R. That means it's a number, like 2, 3, or 2, 3, 4, pi, -7. This would be an element of R5, and x1 is 2, x2 is 3, x5 is -7. Okay. So good. Now we're done with part A. That was part A. Let's do part B. explain the notation A subset R of Rn. Give explanatory examples in dimension 2. So I'll start with pictures. I'll do 2 examples. Here is a nice circle in R2. So I'd say the circle is a one-dimensional subset of R2. Now I'll do another example. Here's another copy of R2 somewhere. And what if I just want to pick out this rectangle here, but I want it to be actually the 2-dimensional rectangle. So, this circle over here is 1-dimensional. It does not include the inside. That would be a unit disk or a ball, we would say. But the circle is just this curve. It's a 1-dimensional curve, 1-dimensional. Here we have this 2-dimensional rectangle is a subset of R2. Okay, and so then, the A subset of Rn means that A is a set of, either points or vectors, contained inside. That's what this symbol means. It means subset of, or contained inside, the n-dimensional space. That's it. It just is a shorthand notation for writing that, if we're talking about this set A, maybe it's this rectangle, well, it lives in R2. That's all. Okay, so words, pictures, formulas. You can pause and look over this. And let's see, I just was quizzing myself. So first I answered it, and I wanted to see, how well can I do? Can I remember everything? Can I say it differently? Can I, what's it look like in a moment? So I had already solved this question. Now you can pause and look at my different solution here, just for an example of another solution, another way to use words, pictures, and formulas and answer these questions.